So today's lesson, after you did this activity today in class, is so what are the official rules and how do I use them? Some of you may have figured some of these out today in class. If you didn't, that's okay. Hopefully you kind of got the idea that there are some general patterns. First rule, if you have a function that is just a constant, so if your f of x is equal to like a 2, it's just a horizontal line, then the derivative is 0. And the reason the derivative is 0 is because the slope of a horizontal line is 0. If you ever have a number times a function, then the derivative is just the number times the derivative of that function. So coefficients don't matter. That's what this basically said. You just take the derivative the same way. Now, I will tell you this next rule is like very, very important. If you ever have a function that has an exponent, then to find the derivative, you drop down the exponent and then you decrease it by 1. So the new exponent is just 1 lower than it was before. So the derivative here would be 3 times x to the second power, 1 less than it was before. It's called the power rule. Super important. Last but not least, derivatives can be added and subtracted. So if you have more than one term, just do each term separately. Okay, here we go. We're off to the races. We're going to do a bunch of derivatives. So, find this derivative. It says take the derivative. For the first term, I would drop the 3, change it to a 2. For the second term, I'm going to drop the 2, but there's already a 6 there. So because we just take a coefficient and we multiply it, we just multiply. 2 times 6 is 12. T to the first power. The invisible power by this t is just a 1. So if you multiply and you drop it, you just get negative 5/3 t to the 0. 1 minus 1 is 0. And the derivative of 16 is just 0. Now this is not as simplified as it gets. T to the 0 is actually just worth 1. We don't really have to write a 0, and we don't really have to write a 1 power. So my derivative here, my final answer, would be 3t squared plus 12t minus 5/3, and you're done. Now if you think back, the long way of finding derivatives, limit as h approaches 0 and all that stuff, this problem would have been the worst to try to solve the long way, and we just did it in like 15 seconds. I love derivative rules. For number 2, y prime, drop it like it's hot. 4x to the third minus 2 times 2, which is 4x to the 1, which I'm not even going to bother writing because I know I'm going to have to simplify it later. And then the derivative of 2 is 0, so I'm donesies. Number 3, y prime, drop it like it's hot. I get 0.8. x to the third. Drop it like it's hot, minus 2.1 x squared. There's an invisible 1 here. Drop it like it's hot. The answer is just 5 x to the 0. X to the 0 doesn't matter. I'm not even going to write it. Plus 4 becomes a 0. We're done. That's it. We're done. Yay, I love derivative rules. And last but not least, some students forget that it's probably easier to simplify and rewrite a problem sometimes. There is a typo here. Please change this x to a 3. Typo alert, change the x to a 3. I prefer, when it has numbers in the bottom, to rewrite those as coefficients. Dividing by 3 is the same thing as having a 1/3. Dividing by 2 is the same thing as having a 1/2. I find that rewriting it first helps. And you'll notice I did not change this to a y prime. I just put an equals because I haven't taken the derivative yet. I've just rewritten the problem. Now I'm going to take the derivative, so y prime equals. Here we go. Drop it like it's hot. 1/3 times 3 is just 1. X squared, decrease it by 1. Drop it like it's hot. 2 times 1/2 is just 1x. Drop it like it's hot. It's just a 1. No x necessary, and we're done. Yee, I love derivative rules. They're so much easier than limits. Ready, set, go. Here we go. These can be applied to things you wouldn't think you could apply them to. So it turns out that anything with a negative exponent, which means there's a variable in the denominator, or a rational exponent, which means the exponent is a fraction, we can still use these exact same rules. Just drop it like it's hot. But it becomes much easier to do that if we rewrite the problem. So first, rewrite. Do not take the derivative yet. Just rewrite all powers with negative or fractional exponents. Then, use the power rule. Drop it like it's hot. Last but not least, rewrite it again. Put it back in its original notation. If the original problem had variables in a denominator, put the variables back in the denominator. Here we go. Let's try it. First, rewrite it. We're still working with the original function here. I haven't taken a derivative yet. I'm just going to rewrite this as 4x to the negative 4 minus 3x to the negative 3. I'm just changing it because when I move it, it becomes a negative power. Then I am taking the derivative. So now I'm changing my notation to f prime because this is the real deal. The derivative is happening. Drop it like it's hot, negative 16. X to the, here's the common mistake, negative 4 minus 1 would be negative 5. It becomes more negativer. A lot of students want to write a negative 3 there because they think, ooh, 4 minus 1 is 3, but we're working with negatives. It's more negativer. Drop it like it's hot. So we get plus 9x to the negative 4, not negative 2, negative 4. We're more negativer. And last but not least, rewrite this problem so that my final answer matches the notation of the original. The variables were in the denominator and they were positive exponents. So I'm going to rewrite this to a negative 16 over x to the 5th plus 9 over x to the 4th, and I'm done. This is my final answer. 3 steps. I want you to number them. I want you to practice them. I want you to get in this habit. It will make your life easier. Number 2. First, we're going to rewrite it. F of x, the original problem, is equal to 3x to the 1/2 power. Please don't forget that a square root is the same thing as a 1/2 power. A cube root would be a 1/3 power. Write them as powers. It makes power rule a lot easier. Then we're really taking the derivative now, so I'm changing my notation. It's a prime because it's the derivative. Drop it like it's hot. 3 over 2, x to the, subtract 1. 1/2 minus 1 would be negative 1/2. Last but not least, rewrite it back in its original form. Because this is a negative power and it's a fraction, it's going to move to the bottom, and I'm going to rewrite it as a square root that happens to be on the bottom. So it's going to the bottom because it's negative. The 1/2 becomes a square root. Next, number 3. First, rewrite the problem. Again, not the derivative yet, just the original in a different notation. X to the, this time the x had a squared. So it just becomes 2/3 because a cube root is just a 1/3 power. Now take the derivative. I'm changing my notation because I'm actually taking the derivative now. This is the real deal. Drop it like it's hot. 2/3 times 3 is just 2. And then I'm going to subtract 1. 2/3 minus 1 is negative 1/3. Then I'm going to rewrite it. Still the derivative, still got that prime. The 2 stays on the top, and it becomes a cubed root on the bottom. This is my answer. Last but not least, number 1 step is just rewrite it. So x to the negative 2 plus 5x to the 4/3. Again, it's a 4th power with a 3 on the bottom. Whatever's inside goes on the top. Whatever's outside goes on the bottom. Now I'm going to actually take the derivative. So drop it like it's hot. Negative 2x to the negative 3, because negative 2 minus 1 becomes more negativer. Drop the 4/3 plus 20/3 x to the, subtract 1, and I get 1/3. Now last but not least, I'm going to rewrite it. So the derivative would equal negative 2 divided by x cubed plus 20/3 times the cube root of x. And I'm done. That's power rule. You gotta love it. It makes things so much faster than when we had to use limits. I'm looking forward to seeing you tomorrow. Have a great